Now let us see how we are going to solve questions on projectile motion. Right? Everybody must have read the formulas, but the real problems comes in projectile motion while solving the problems. How do we proceed? Right? Now let us look at an example. Now this example says that a stone is thrown with a velocity of 19.6 meter per second at an angle of 30 degree above horizontal from the top of a building which is 14.7 meter high. Right? Now this building is 14.7 meter high, and a person is throwing a stone with a velocity of 19.6. That means we are given u is equals to 19.6, right, meter per second, and theta is 30 degree above horizontal from the top of a building, and 14.7 meter high it is given. We have to find the time after which the stone strikes the ground. Right? Now first of all, the most important thing is, when we see the question, you might be guessing that it can be done by using the formula for time of flight, which is 2u sine theta by g. Right? Most of you will be doing this thing, but this is a mistake. Right? We cannot apply this formula for the total time of flight when the initial point or the starting point and the landing point are not at the same horizontal level. Right? There is a difference. Horizontal level is not the same. It is starting at O and it is landing at C. They are not in the same horizontal plane, so we cannot apply this formula. It can be only applied if the projectile would have gone from O to probably a point which is D. Right? This would have been the total time of flight, but DC path is extra. We have to calculate the time for the entire path from OBDC. Right? Now for solving these kind of questions, when we cannot apply the basic formula, what we do is we basically divide the entire motion into two parts. First is the vertical. Right? Vertical equations can be used, and for horizontal. Right? Now here we are given that we have to calculate the time. Now the problem is, how will we proceed? We will use will we use the vertical motions or the horizontal motions? If we see over here, we have to calculate the time. For horizontal, we know that ax is 0. Right? So that means the only equation that we can use is v is equals to u. That means the horizontal motion will remain the same, which will be equal to u cos 30 degree. Right? This will be equal to vx, so this will be equal to ux, and this will be u cos 30, or which will be equal to 19.6 into cos 30. Cos 30 is what? Root 3 by 2. Right? So this will remain the same. And what will be Sx in this case? Sx will be equal to ux into t. Right? So only one equation we can use, because the other equation uses acceleration, and acceleration is 0. Right? So this is the only equation. Now if we have to find time using this equation, we have to know the other two quantities. Ux we know, which is 19.6 into root 3 by 2, but Sx is unknown. Right? So we cannot use this formula for finding out the value of time. So let us come to the vertical part. We see over here that Sy is given to us. Right? It is going from O to C. So we have the equation Sy is equals to uy into t minus half gt square. Right? What we have done is we have taken the downward direction as negative and upward direction as positive. Right? So since g will be in the downward direction, let us take it at minus g. So Sy will be equal to what? Minus 14.7, because it is going from O to C. So it is also negative. And what is uy? Uy is the initial velocity, which is in the upward direction. Uy, which will be equal to what? U sine 30. Am I right? So this will be equal to u sine 30, or 19.6 into 1 by 2. Right? Sine 30 is what? 1 by 2 into t minus half. This we can take as 9.8 into t square. Right? G. Now if we solve this, we will get if we solve this quadratic equation, we will get t as -1 and 3. Since time cannot be negative, that means the only correct answer will be t is equals to 3 seconds, right? So this is how we proceed. We basically divide it into two parts, horizontal and vertical. Now, the first part we have calculated. This was basically the first part. Now let us move on to the second part. Now, what is second part asking? The distance of the landing point of the stone from the building, right? So that means Sx, this path, AC it is asking. Now what is this? AC is horizontal distance. So that means we have to come to the horizontal motion. Now it is asking Sx. Now we know Ux, which is 19.6 into root 3 by 2, and time going from O to C. Now we have calculated in the first part. So we can very well use this equation. Sx will be equal to Ux into t, which will be equal to 19.6 into root 3 by 2 into time t, which is 3, right? So when you calculate this, you will get an answer of 50.92 meters, right? So we have calculated the second part also. Now let us see the third point. Now the third part says the maximum height attained by the stone above the ground. That means this height plus 14.7. H is the maximum height, right? So how do you solve this? Most of you will be again doing the same mistake. They will be using the formula of maximum height, which is u square sine square theta upon 2g, right? But no, this is wrong, because the total height is not only h. It is h plus maximum height. H max will be equal to what? H plus 14.7, because it is saying from the ground, and maximum height is above the horizontal. What we calculate is this part. If we apply the formula h is equal to u square sine square theta upon 2g, this will give us the value of the small h, this portion only. Basically, if we mark this as E, so this will be giving us only the value of BE. But if this part is F, we need H max will be equal to what? BF, which will be equal to what? BE plus EF. And what is EF? EF is 14.7, right? So what we do is we calculate H. H will be given by this equation. So how will we calculate this H? H will be equal to u square sine square theta. U square sine square theta, which will be equal to 19.6 into 1 by 2 whole square, right? U square sine square theta divided by of 2 into 9.8. Now if you calculate, you'll get the value as 4.9, right? You will get the value as 4.9. So this will give you value of 4.9 plus 14.7, which will be equal to 19.6 meters, right? So this is the answer. So this is how you solve basically the questions. When we read the theory, projectile motion looks very simple, right? But there is a different altogether strategy for solving the questions. We have to see either we can apply these formulas or not. Total time of flight, maximum height and range. It can be only applied when the starting point and the landing point are in the same horizontal plane. This is very important. If they are in the same horizontal plane, only then you can apply these formulas. If these are not in the same horizontal plane, you have to go by the basic methods, which is calculating the values using vertical motion equations and the horizontal motion equations, right? Just be careful while solving the questions. There is a definite chance that a question on projectile motion will be coming in IITREE, right?